In this lecture, we'll look at how we convert expressions from infix notation to postfix notation. If we're going to evaluate an expression in the postfix notation, well, we kind of need to have the expression in that notation. So we have to be able to convert the expression into the postfix notation. Now, the good news is that we can use a stack to do this conversion for us. So we can convert from standard form, which is also known as infix notation, into the postfix notation. I should caution you, though, that this is a very involved and complex process. So feel free to stop the video and rewind if you need to make sure you understand how this works. And to make the explanation simpler, we're going to restrict ourselves to just single-digit numbers. We can easily have multi-digit numbers, but we're going to use single-digit numbers, and the expressions may evaluate to double or triple-digit numbers or just multi-digit numbers. That's fine, but we're going to try to explain this as simply as possible. Before we go over the translation process, let's take a look at how we would evaluate normal infix expressions. Whenever we're evaluating an expression in infix notation, there are several rules that we need to follow. The first one is that we read the expression from left to right. The second rule is that whenever we read enough to actually evaluate two of the operands, then we would do the calculation. So we would need to read two operands and then an operator. So we do the calculation, and then we substitute the answer in place of that portion of the expression. And then we just continue until we're at the end of the expression. Let's do an example. Let's say we want to evaluate 3 plus 4 minus 5. So we're going to read each part of this expression one at a time. So we read a 3, and that's just an operand, but we can't do any evaluation just yet. We then read the plus. So at this point we have 3 plus, that's been parsed so far. We then read the 4. So now at this point we have 3 plus 4, and according to our second rule, we should be able to go ahead and evaluate this and give us a 7, right? Well, not so fast. We can't evaluate this yet because we don't know what the next operator is. If it's a multiplication symbol or a division symbol, that's going to take higher precedence. So we need to at least see what the next symbol is before we would evaluate this portion of the expression. We read a minus sign, so since that's at the same precedence level as the plus sign, we can do 3 plus 4. We can evaluate it. That gives us a 7, so we put that in place for our expression. We'll then include the minus sign in the parse. We've already read the minus sign. We did the evaluation, so now we will put that in the expression that we have parsed. We then read the 5, so we add that to our list of parsed symbols. So we have 7 minus 5. And we find that we're at the end of the expression, so we know we can evaluate 7 minus 5. So when we evaluate it, we get 2, so that's going to be the result of our expression. So just a couple of notes from that last example. I mentioned it, but I want to reiterate it. When we had the 3 plus 4, we couldn't evaluate it just yet. We needed to know what the next operator was, because if it was something like multiplication, we can't evaluate that yet because multiplication does have a higher precedence over addition. Now, if it were 3 times 4, that's a different story. So we have to keep in mind the precedence levels or the order of operations when we're evaluating our expressions. Let's do another example where we evaluate 3 plus 4 times 5. We'll read the 3, which is an operand, so we can't do anything just yet. We then read the plus, so we have an operator. We then read the 4, and just as before, we don't know what the next symbol is, so we can't evaluate 3 plus 4 just yet. We next read the multiplication symbol, which means we cannot do 3 plus 4 because we know that whatever comes after this multiplication symbol, we have to multiply it with the 4. We now read the 5, so we have the 4 times 5. We can evaluate that portion of the expression. We see that gives us 20, so now our parsed expression so far is 3 plus 20. And since we're at the end of the expression, we can evaluate this part as well. So we see that when we add them, we get 23, which is the result of our expression. In general, when we think we can evaluate an addition or subtraction expression, we have to hold off just a little bit. We need to check the next operator to see if it's a multiplication or a division symbol or if it's something else, because we have to make sure that precedence is preserved. So whenever we get an addition or subtraction expression, we can't evaluate it just yet. We have to see what comes next. Now here's an interesting question. What if we have parentheses in our expression? Well, that just completely changes the game here, because parentheses have a higher precedence over everything else. So regardless of whether you're dealing with addition or multiplication or subtraction or division, parentheses just makes everything all, it's just more interesting, I'll put it that way. Let's try this example where we're going to evaluate 3 times and then in parentheses 4 plus 5. So we already see that when we read the parentheses, that's going to alter how we handle evaluating the expression. We first read the 3, so nothing out of the ordinary here. We then read the multiplication symbol, nothing out of the ordinary just yet. We then read the parenthesis, the left parenthesis, so we add it to our parsed expression. And what we can tell is we can't do anything with the 3 and the times symbol just yet. We're going to have to handle whatever's in the parentheses first. We then read the 4, and technically we have 3 times 4 in here, but we can't evaluate it yet because we have that parenthesis in between. We have to take care of that first. We next read the plus sign and add it to our parsed expression. We then read the 5. So now we have 4 plus 5. But we have to check what comes next, because we may get a multiplication symbol, we may get the closed parentheses. We don't know at this point, so we need to make sure we check what comes next. We see that we do get the closed parentheses. So now that we have our parentheses completed, we can evaluate 4 plus 5. 4 plus 5 evaluates to 9, so our expression is now 3 times 9, and we can easily evaluate that expression. This gives us a 27. And we see we're at the end of our expression, so our final result is 27. So what we're seeing here is the idea with this evaluation is we read one character at a time. Whenever we get an expression, we would evaluate it. Now, with that said, we first have to check what type of expression it is. If it's an addition or a subtraction expression, we need to check the next operator to make sure that it's not the next thing is not a multiplication or a division symbol. If that's the case, though, if we encounter the multiplication or division symbol, we need to handle that expression first. Now, this seems like a pretty straightforward algorithm. So we could write an algorithm for evaluating our infix notation expressions. That's fine. But what we find is it's actually easier to evaluate the expression if we translate it into the postfix notation first. So that's why we even talked about the postfix notation in the first place, because evaluating expressions there is a lot easier than evaluating expressions in infix notation.